on with section 5.3. This is the second day. And so what I have for you is some tips for solving these trig equations. So if you remember on Thursday, we went through and solved the trig equations, and we actually used the first two tips. And then we're going to go ahead and look at some other ones that kind of can help you complete your homework. So the first one says, if the equation only has one trigonometric function, isolate it. So what that means is you get it all by itself. So like you might get sine x to equal 1 or sine x to equal root 2 over 2, but you get that trig function all alone by itself. Okay, the second step is to factor. So we've looked at both of these steps. That should be nothing new. The third step is to substitute an identity. So what exactly that means is, say for example, I had like 1 minus sine squared x. What do I know 1 minus sine squared equals? Cosine squared. So I might substitute that into the equation in order to kind of help me solve it. Another option is to square each side. If you do this, you must check your solutions. So these are just some helpful tips. If they work for you, great. If not, kind of go back to whatever works for you. And so it says find all solutions of each equation on the interval 0 to 2 pi. Same instructions we've had, so all you can do is just kind of pick up in your notes. And we're going to go ahead and solve this first equation. And we've just got two equations we're going to look at today, and then you should be good for your homework. So first of all, I have sine squared minus sine plus 1 equals cosine squared. Whoo! So in looking at those, you see that you've got some trig functions, and you have one trig function that maybe doesn't belong.
Sine.
Which trig function doesn't belong?
Oh, I don't know. 1.
So you've got a sine squared, a sine, and a cosine squared. Yeah, the cosine doesn't belong because the other ones you've got a sine squared and a sine. So what I'm going to do is I'm going to substitute an identity. And so first of all, I'm going to go ahead and leave sine squared minus sine plus 1. And on the right side, I'm now going to write cosine squared as
Sine squared minus 1.
close.
Sine 1 minus sine squared.
1 minus sine squared. There you go. And so now in looking at that, I'm going to go ahead and try to solve that. So first of all, I notice I've got a 1 on each side, right? So those are gone. So now I'm going to move my negative sine squared over to the left. So on the left side, I'm now left with 2 sine squared x. Okay, because that's what sine squared plus sine squared is, because it's 1 sine squared plus 1 sine squared, minus sine x. And what will that equal? What will that equal?
0.
0, because that's what you substituted in 1 minus sine squared for. Yes?
But if you move the sine squared over to the other side, you just have like negative sine on one side and sine squared.
No, I moved this one over here. So I have sine squared plus sine squared, which is 2 sine squared. Over here on the right, I have negative 1 sine squared plus 1 sine squared. Those cancel, leaves you with 0. So on the left side, you have 2 sine squared. You have
Are we
a
trying
negative
to do
sine.
Oh.
And so in order to solve this, I'm going to factor out a sign, because each of those has a sign. And when I take a sign out from that first bunch, what do I have?
Sine squared.
Sine.
Sine.
Yeah, 2 sign. Okay.
Oh, without the sine squared.
Right, and then minus what? 1. So basically, all I did is took a sign out. And so now I'm going to apply my zero product property. Zero product property states, in this case, that either sine x equals 0, or, what else?
2 sine x
Yep.
minus 1.
2 sine x minus 1 equals 0. So first I'm going to go to my blue sheet, and I'm going to find out where does sine equal 0. And there should be 2 values for you.
0
And,
pi.
okay, 0
2
and pi. Okay, aren't going to use 2 pi because we're just going to go from 0, and we're not going to include the 2 pi. In order to solve this, I'm going to add 1 to both sides,
Divide by 2.
and then divide by 2. So sine x equals 1/2. So your best friend blue sheet now says,
Pi over 6.
and
5 pi over 6.
5 pi over 6, very good. So we have a total of 4 different solutions. Those are the 4.
Well, we get to use our blue sheet.
Yes.
Okay, so why don't we use 2 pi down at the bottom?
Because this, remember, means you don't include. Remember the parentheses mean you didn't include. The bracket meant you did include. Okay. So, let's go and look at another one. Now, there's an algebraic way to do this, and there's another way to do this. Okay? The algebraic way entails some work. It entails moving a trig function to the right side and squaring. I think that there's an easier way to do that, and let's just go and look at this. This says sine minus cosine equals 1. Right? So on your blue sheet, you have a sine column. You have a cosine column, right?
Mm-hmm.
So I want to look at that, and I want to see where does sine minus cosine equal 1. So if I start at 0 degrees, sine is what?
0.
0. Cosine is what?
1.
So I get 0 minus 1. Does that equal 1? No. So do you see kind of what I'm going to do? I'm just going to compare those two columns, and I'm going to look and see where do I get 1. So let's go to 30. I have 1/2 minus root 3 over 2. Does that give me 1? No, because it's got a square root. So go to the next one. What does that give me when you subtract them? 0. Okay, doesn't give me 1. Okay, keep going.
No.
Yes.
90.
90. Okay, 90 works. Are there any others?
No. That's -1 minus 0.
Which one?
Number 270.
270? Really? Isn't 270 this?
No, that's 180. 270 is -1 minus 0.
Okay, so this is 180, right? 0 minus -1. Doesn't that give you +1?
Which one's that?
180. Hi.
90 and 180.
Yep. So you actually have 2 solutions here. And like I said, there's an algebraic way to doing this, and you could do this, that's fine. Or what you could do is you could just use your blue sheet and do it kind of a logical way here. So, any questions? All right, this is what you need to do.
Stupid.
You need to add 6
Only
questions.
6 questions?
6 questions to 1 through 18.
Thank you, Master. Thank you.